Good day everyone. Today I'll be showing you how to solve simultaneous equation using the matrix method, the substitution method and the elimination method. But first I will show you the basics as regards to matrix. As in finding the determinant of a matrix and finding the adjoint of a matrix. Hence finding the inverse of a matrix. So a 2 by 2 matrix would be having elements such as A, B, C and D. That would be a 2 by 2 matrix. To find the determinant of this matrix, it will be AD minus BC. This will be the determinant of the matrix. This will be the determinant of the matrix here. So that will be the determinant of the matrix. The adjoint of the matrix here now of this matrix. This matrix will be A. Call this matrix A. So the adjoint of this matrix would be, you would interchange the leading diagonal, which would be AD. So this is what you do. Leading diagonal minus non-leading diagonal will be equal to determinant. But the adjoint now, you interchange the leading diagonal. Now you'll have D A, and you'll negate the non-leading diagonal. So you have minus B and minus C. Minus C, not minus 3. Minus C. So that will be the adjoint. So I'll be showing you this using the numbers. So I will have a matrix like 3, 2, 3, 4. You want to find the determinant of this matrix. As I said, it will be leading diagonal minus non-leading diagonal. So it will be 3 times 4 minus 2 times 3. And that will be equal to 12 minus 6. And 12 minus 6 will be equal to 6. So 6 would be the determinant of this matrix. And we'll find the adjoint of this matrix now. So it will be 4, 3. We interchange the leading diagonal, negate the non-leading diagonal, so it will be 2, negative 3. We want to find the inverse of this matrix, inverse of A. So we'll multiply by a scale factor of the inverse of the determinant. So the inverse of the determinant will be 1 over 6. 1 divided by 6. So we'll multiply this by 1 divided by 6. 1 6. In this case, it will be equal to 4 divided by 6. 4 6. And then negative 2 6. And then negative 3 6. And 3 6. So that will be the inverse. This will be the inverse of the matrix. What we have right here will be the inverse of the matrix. Inverse of this matrix. So I'll go ahead and I'll show you how to multiply a 2 by 2 matrix by a 2 by 1 matrix, because that's what we'll be doing in solving simultaneous equation using matrix. So say we have 2, 3, 4, 2. We are multiplying this matrix by 6, 3. What we'll do now is multiply row by column. So this will be row 1, column 1. So for row 1, column 1, we'll have 2 times 6 plus 3 times 3. So 2 times 6 plus 3 times 3. That's for row 1, column 1. So for row 2, column 1, we'll have 4 times 6 plus 2 times 3. 4 times 6 plus 2 times 3. And that will be equal to 12 plus 9 and 16 plus 6. And 16 plus 6 will be equal to 22. So that will be equal to 12 plus 9 will be equal to 21. 21 and 22. And 22. That will be 21 and 22 would be the product of these two matrices. So now we'll go ahead and try to solve a simultaneous equation using the matrix method. The simultaneous equation that we'll use to solve will be 2x plus 3y equal 21. And we'll also have 4x plus 3y equal 27. So what we'll do now, we'll use the coefficients of the variables in a matrix, in a 2 by 2 matrix, and we will call it A. A equal 2, 3, 4, and 3. We'll multiply it by the solution matrix and we'll call it B. So B equal, now we will not multiply it by the solution matrix as yet, but B equal, the solution matrix will be 21 and 27. So we are going to solve this equation. What we'll have to do is, it will be equal to, so x, y would be equal to A inverse times B. So in other words now we'll find the determinant of A. Because you want to find A inverse, you'll have to find the determinant of A and multiply it by the adjoint. The determinant of A now will be leading diagonal minus non-leading diagonal. So in this case, we'll have 2 times 3 minus 4 times 3. So we'll have 6 minus 12. So the determinant would be minus 6. So in this case, we'll have 1 over minus 6. 1 divided by minus 6 times adjoint. And the adjoint would be interchanging the leading diagonal 3, 2, and negating the non-leading diagonal 3, negative 4 times B, which is a solution matrix. That will be 21, 27, and that will be equal to xy. So now we'll go ahead and leave the scale factor of negative 1/6, and we'll multiply these two matrices. So we'll have now 3 times 21 plus negative 3 times 27. That's for row 1, column 1. Then we'll have negative 4 times 21 plus 2 times 27. You'll go ahead and keep the scale factor still. So we'll have negative 1/6. 3 times 21 would be 63. So 63 plus negative 3 times 27 would be negative 81. So it will be minus 81. So, and then we'll have row 2, column 1 now. Row 2, column 1 will have negative 4 times 21 would be negative 84. And 2 times 27 would be 54. And that will be equal to xy. Now we can go ahead and add these. Keep the scale factor of negative 1/6, and we'll 63 minus 81, we'll get a negative 18 there. And 84 minus 54, we'll get a negative 30 there. The scale factor is negative, and these are negative. And a negative number times a negative number would be a positive number. So we'll have, this would be 18 over 3, and we'll have 18 over 6, sorry. 18 over 6, sorry, and 30 over 6. And that will be equal to xy. So 18 divided by 6 will be 3, and 30 divided by 6 will be 5. So x equal 3 and y equal 5. So we have just solved the simultaneous equation using a matrix. Now we'll solve the same equation by using the substitution method. And we should get the same result. So using the substitution method, we can either make x or y the subject of any of these equations. So I will make x the subject of equation 1. So I'll have 2x plus 3y equal 21. So I will transpose to make x the subject. So I'll have 2x equal 21 minus 3y. So I'll have now 2x, sorry, 2x divided by 2 equal 21 minus 3y divided by 2, because anything we do to one side we have to do it to the other. So now we can separate these because it's minus and you have the same denominator. We can separate it or we can leave it the same way, but I rather separate it. So I'll have x equal 21 over 2 minus 3y over 2. So this, we can substitute this for x in the other equation. So now I'll have 4 times 21 over 2 minus 3y divided by 2 plus 3y equal 27. Equal 27. So this now 4 times 21 will be 84. 84 over 2 minus 12 over 2, 12y over 2, and that will be plus 3y equal 27. So 84 divided by 2 will be 42. And 12y divided by 2 would be negative 12y divided by 2 will be negative 6y plus 3y equal 27. So negative 6y plus 3y will be equal to negative 3y. And then we'll have this to equal to 27 minus 42. Sorry. So therefore we'll have 3y equal negative 15. So therefore 3y, negative 3y equal negative 15. So 3y equal 15. So 3y divided by 3 equal 15 divided by 3. So y would be equal to 5. So you see, I got y to be 5. Now I think I have this. So I will substitute 5 for y in one of these equations. So I'll use equation 1. And so I'll have 2x equal 3 times 5 plus 3 times 5 equal 21. Now I'll have 2x equal 20. 2x equal 2x plus 15, sorry. 2x plus 15 equal 21. I don't want to miss any step. So therefore now I'll have 2x equal 21 minus 15. So 2x will be equal to 6. 2x will be equal to 6. So 2x divided by 2 equal 6 divided by 2. So x will be equal to 3. So we got the same result as we got in the matrix. So what I will do now is I will solve it using the elimination method now, and I should get the same result again. So we'll erase that part and we'll. So when you're using the elimination method, you want to make the coefficient of one of the variables be equal to 0. So what I will do now, I will let the coefficient of y, the sum of the coefficient of y will be equal to 0. Sum of the coefficients of y will be equal to 0. So therefore I'll multiply one of the equation by -1. Any one of them I will, because it's -1. So I'll have 2x here. 2x plus 3y equal 21. I'll multiply this one by -1, so I'll have -4x plus minus 3y minus 3y equal 27, -27. So what I will do now is I'll go ahead and add the equations together. So this is already 0, so I can eliminate that. And we'll have now 2x plus 4x. So that will be 2x minus 4x, that will be equal to -2x. -2x would be equal to 21 minus 7. 21 plus -7 will be 21 minus 7. So that will be equal to 6. -6, yes. So we'll have now 2x equals 6. So 2x over 2 equals 6 over 2. So x will be equal to 3. So we got the 3. Now, as we did in the method before, we'll substitute 3 for x in any one of these equations. So I'll use equation 1 again. I'll use 2 times 3 plus 3y equal 21. So this 2 times 3 here would be 6. So I'll have 6 plus 3y equal 21. Now I'll transpose here, so I'll have 3y equal 21 minus 6. So 3y will be equal to 15. 21 minus 6 will be equal to 15. Then 3y divided by 3 equal 15 divided by 3. So y will be equal to 5. So we get the same result again. So I will give you another equation for you to go ahead and solve. So 3x minus 4y equal 4. And 6x plus 4y equal 32. You can go ahead and try to solve. You can go ahead and try, pause the video and try to solve that equation. Now, as you can see, the sum of this coefficient is already equal to 0, so we can eliminate this immediately. We don't have to multiply by anything. So what I will do now is just go ahead and add these equations. So 3 plus 6 will be 9x. 3x plus 6 will be 9x. This will be 0, so we'll go ahead and say 9x equal 4 plus 32, which will be 36. So 9x divided by 9 will be equal to 36 divided by 9. So x will be equal to 4. So as I have done before, we will substitute 4 over x in any one of these equations. Again, I will use equation 1. So I'll have now 3 times 4 minus 4y equal 4. This will be now 3 times 4 will be 12. So 12 minus 4y, sorry, equal 4. So this will be now minus 4y equal 4 minus 12. 4 minus 12. So minus 4y equal minus 8. So this will be 4y equal 8. 4y divided by 4 equal 8 divided by 4. So y would be equal to 8 divided by 4, and 8 divided by 4 will be equal to 2. So in that case we have x equal 4, y equal 2. I don't know if you want me to solve it using the matrix method as well. I guess you know what to use. I will go ahead and use this matrix method and solve it. So therefore I'll have 3 minus 4, 6, 4. The determinant of this would be 3 times 4 minus 3 times negative, minus 6 times negative 4. So this would be 12 minus 24. So 12 minus 24 will be 12 plus 24. So the determinant of this would be 32. It will be 36, sorry. It will be 36. So therefore, we'll have inverse of this times solution matrix will be 4 and 32. And that will be equal to x, y. So you know the determinant of this was 36. So we'll have 1 over 36, 1 divided by 36, times the adjoint of that matrix, times the adjoint of this matrix we can call it. So that will be, no, we'll interchange the leading there and all that. We will have 4, 3, 4, negative 6. That times solution matrix equal xy. We'll go ahead and still keep the scale factor of 1 over 36, and then we'll multiply the two matrix. So this will be 4 times 4 plus 4 times 32. So we have negative 6 times 4 plus 3 times 32 equal xy. We'll still keep a scale factor here. 136. So we'll have here 4 times 4 will be 16. 4 times 32 here would be 4 times 32 here would be 144. 140, not 144. Sorry. 142. Four times 32 here. 2 times 72 will be, yes, 144. It's not 144. For that. Sorry. It will be 128. Sorry. 128. So, and then negative 4 times negative 6 times 4 will be negative 24. Negative 24 here. And 3 times 32 would be 96. Plus 96. So this would be 1 over 36. So 16 plus 128 would be 144, right? Yeah, 144. That's where I was getting the 144. And 96, negative 24 plus 96 would be 72. Then we'll go ahead and multiply it by the scale factor here now. So 144 divided by 36 would be equal, and 72 divided by 36 would be equal to xy. Would be equal to xy.